Okay, we start lecture 10. Before the discussion of KVL and KCL, we need to define some terms with the example of this circuit. The first concept is a branch. Several elements connected to each other without any derivation form a branch. For the circuit, this is a branch. That elements connected head to end without any derivation. This is another branch. This is a third branch. This junction separates the three branches. So the amount of the branch is 3 in this circuit. The second concept is a node. A node is a junction point connecting 3 or more branches. It is clearly in the figure. This and that are 2 nodes respectively. So we have 2 nodes. The third concept is a path. A path is the branches between 2 nodes. For example, we define nodes as A and B. Paths between node A and node B include 3 paths. That is path 1, path 2, and path 3. The fourth concept is a loop. A loop is a closed path. That is to say, a loop is a path whose start point and end point are the same node. For this circuit, it is obviously that this is a loop, and this is a second loop. Are there more? Yes. This is a third loop. So the amount of the loop is 3 for this circuit. There is a special loop called mesh. A mesh is a loop which has no intersections with other branches. It needs to be defined in the planar circuits. The planar circuits have been introduced in lecture 2. For this circuit, L1 is a mesh. L2 is a mesh 2. But L3 is not a mesh because there is an intersection between L3 and the branch. It needs to be noted that in some other textbooks, a branch is defined as any element with 2 terminals. So according to this definition, this is 1, 2, 3, 4, 5. There will be 5 branches. The terminals between 2 elements is then called a node. So this is the first, the second, the third, the fourth. They are 4 nodes altogether. So the amount of the branch and the node in a circuit may be different according to different definitions. After the discussion in lecture 11, we will know the different number of the branches and the nodes will cause a different number of equations. But this is not important. No matter how we define the branch and the node, we can list sufficient number of equations to find all the variables of the branches. We adopt this definition method rather than the way in this course.